The National Electrical Code, or NEC, defines a mobile home as a factory-assembled structure or structures transportable in one or more sections built on a permanent chassis, designed to be used as a dwelling when connected to the required utilities. According to the NEC, the electrical service for a mobile home must be mounted on a pedestal base or another listed and approved support structure. Pedestals are typically constructed of concrete or metal with a dedicated compartment for the electrical service equipment. However, there are a few exceptions to the requirement for pedestal-mounted electrical service for mobile homes. Firstly, if the mobile home is installed on a permanent foundation and will not be relocated. Secondly, if the electrical service is provided through an underground raceway. A situation where a trailer is considered mobile due to its steel framing and potential to be moved, but it is also placed on a permanent foundation, falls into a grey area. To avoid potential code violations and ensure safety, it is recommended to follow the NEC requirement and install the electrical service on a pedestal base. This will provide a dedicated and stable support for the electrical equipment and minimize the risk of electrical hazards. If aesthetics are a concern, there are various pedestal-based designs available that can blend in with the surroundings. Concrete pedestals can be painted or stained to match the exterior of the trailer, while metal pedestals can be concealed with landscaping or decorative panels. Understanding the NEC requirements for mobile home electrical services is crucial for ensuring safety and compliance. The code specifies that electrical services for mobile homes must be mounted on a pedestal base or another listed and approved support structure. These pedestals are commonly made of concrete or metal and include a dedicated compartment for electrical service equipment. This requirement exists to provide a stable and secure foundation for the electrical service, reducing the risk of hazards. However, there are exceptions to this rule. If a mobile home is installed on a permanent foundation and is not intended to be relocated, or if the electrical service is supplied through an underground raceway, the pedestal requirement may be waived. In situations where a trailer is classified as mobile due to its steel framing and potential for relocation, yet it is situated on a permanent foundation, a grey area arises. To navigate this ambiguity and prioritize safety, it is advisable to adhere to the NEC guidelines and install the electrical service on a pedestal base. This approach ensures a dedicated and stable support for the electrical equipment, minimizing the likelihood of electrical hazards. Furthermore, aesthetic concerns can be addressed by exploring various pedestal-based designs that harmonize with the surroundings. Concrete pedestals can be customized with paint or stain to match the trailer's exterior, while metal pedestals can be concealed using landscaping or decorative panels. The primary objective is to ensure that the electrical service is installed safely and in accordance with code requirements, while also considering the visual appeal of the installation. When dealing with mobile home electrical services, several key considerations come into play to ensure safety, compliance, and functionality. Firstly, it is essential to understand the definition of a mobile home according to the National Electrical Code, or NEC. This definition provides a framework for determining the applicable regulations and requirements. Secondly, the NEC mandates that the electrical service for a mobile home be mounted on a pedestal base or another listed and approved support structure. Pedestals offer a stable and secure platform for the electrical equipment, reducing the risk of damage or hazards. Thirdly, there are exceptions to the pedestal requirement. If the mobile home is permanently installed and will not be moved, or if the electrical service is provided via an underground raceway, the pedestal may not be necessary. Fourthly, grey areas can arise when a structure exhibits characteristics of both a mobile home and a permanent dwelling. In such cases, it is prudent to consult with local electrical inspectors or qualified professionals to determine the most appropriate course of action. Fifthly, aesthetic considerations can be addressed through careful selection of pedestal designs and materials. Options include concrete pedestals that can be painted or stained, as well as metal pedestals that can be concealed with landscaping or decorative elements. By considering these factors and adhering to NEC guidelines, it is possible to achieve a safe, compliant, and visually appealing mobile home electrical service installation. When installing an electrical service for a mobile home, it is important to prioritize safety, compliance, and functionality. Firstly, ensure that all work is performed by a qualified and licensed electrician who is familiar with the NEC requirements for mobile homes. Secondly, carefully inspect the existing electrical system to identify any potential hazards or deficiencies. Address these issues before proceeding with the new installation. Thirdly, select a pedestal base that is appropriately sized and rated for the electrical load. Ensure that the pedestal is securely mounted to a stable foundation. Fourthly, use only listed and approved electrical equipment and materials. Follow the manufacturer's instructions for installation and operation. Fifthly, properly ground the electrical system to protect against electrical shock. Use a grounding electrode system that meets the requirements of the NEC. Sixthly, install overcurrent protection devices, such as circuit breakers or fuses, to protect against overloads and short circuits. Size the overcurrent protection devices appropriately for the electrical load. Seventhly, clearly label all electrical panels and circuits. This will help with future troubleshooting and maintenance. Eighthly, provide adequate clearance around the electrical equipment for safe access and maintenance. Ninthly, inspect the completed installation to ensure that it meets all applicable codes and regulations. Tenthly, obtain the necessary permits and inspections from the local authorities. By following these guidelines, you can help ensure a safe and reliable electrical service for your mobile home. The NEC provides specific guidelines for mobile home electrical services, aiming to ensure safety and compliance. These guidelines address various aspects of the installation, including the location and type of service equipment, wiring methods, and grounding requirements. When installing an electrical service for a mobile home, it is crucial to adhere to these guidelines to minimize the risk of electrical hazards. Firstly, the NEC requires that the electrical service for a mobile home be mounted on a pedestal base or another listed and approved support structure. This requirement ensures that the service equipment is adequately protected from physical damage and environmental factors. Secondly, the NEC specifies the minimum size and type of service entrance conductors. The conductors must be sized to carry the anticipated electrical load of the mobile home, and they must be suitable for the environmental conditions. Thirdly, the NEC outlines the acceptable wiring methods for connecting the mobile home to the electrical service. These methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Fourthly, the NEC mandates that the electrical system be properly grounded to protect against electrical shock. The grounding system must include a grounding electrode system, such as a ground rod or ground plate, and a grounding conductor that connects the service equipment to the grounding electrode system. Fifthly, the NEC requires that overcurrent protection devices, such as circuit breakers or fuses, be installed to protect against overloads and short circuits. The overcurrent protection devices must be sized appropriately for the electrical load. Sixthly, the NEC specifies the location and type of receptacles and lighting fixtures that are permitted in mobile homes. The receptacles and lighting fixtures must be listed and approved for use in mobile homes. Seventhly, the NEC requires that all electrical work be performed by a qualified and licensed electrician who is familiar with the NEC requirements for mobile homes. By adhering to these NEC guidelines, you can help ensure a safer and compliant electrical service for your mobile home. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. When dealing with electrical installations, safety is paramount. Several key safety precautions should be observed to prevent electrical shock, fire, and other hazards. Firstly, always turn off the power at the circuit breaker before working on any electrical equipment. This will prevent accidental electrical shock. Secondly, use insulated tools when working on electrical equipment. Insulated tools provide a barrier between you and the electrical current. Thirdly, never work on electrical equipment in wet or damp conditions. Water is a conductor of electricity and it can increase the risk of electrical shock. Fourthly, inspect electrical cords and plugs for damage before using them. Damaged cords and plugs can create a fire hazard. Fifthly, never overload electrical circuits. Overloading a circuit can cause the circuit breaker to trip or the wires to overheat, leading to a fire. Sixthly, use ground fault circuit interrupters, or GFCIs, in wet locations, such as bathrooms and kitchens. GFCIs can detect ground faults and quickly shut off the power to prevent electrical shock. Seventhly, install smoke detectors and carbon monoxide detectors in your home. Smoke detectors can alert you to a fire, and carbon monoxide detectors can alert you to the presence of carbon monoxide, a deadly gas. Eighthly, have your electrical system inspected by a qualified electrician on a regular basis. A qualified electrician can identify potential hazards and make repairs before they become a problem. Ninthly, if you are not comfortable working on electrical equipment, call a qualified electrician. It is always better to be safe than sorry. Tenthly, follow all applicable codes and regulations when installing or repairing electrical equipment. Codes and regulations are designed to ensure safety. By following these safety precautions, you can help prevent electrical accidents and protect yourself and your family from harm. Mobile homes present unique challenges when it comes to electrical installations due to their construction and intended use. Understanding these challenges is crucial for ensuring safety, compliance, and functionality. Firstly, mobile homes are typically constructed with lightweight materials, which can make it difficult to securely mount electrical equipment. This requires careful selection of mounting hardware and techniques. Secondly, mobile homes are often located in areas with limited access to utilities, which can complicate the installation of electrical services. This may require the use of alternative power sources or specialized wiring methods. Thirdly, mobile homes are subject to movement and vibration, which can stress electrical connections and components. This necessitates the use of vibration-resistant materials and techniques. Fourthly, mobile homes are often exposed to extreme weather conditions, which can affect the performance and lifespan of electrical equipment. This requires the use of weather-resistant materials and techniques. Fifthly, mobile homes are subject to specific codes and regulations that may differ from those for conventional dwellings. This requires familiarity with the applicable codes and regulations. Sixthly, mobile homes often have limited space, which can make it challenging to install electrical equipment and wiring. This requires careful planning and layout. Seventhly, mobile homes are often occupied by residents with limited electrical knowledge, which can increase the risk of electrical hazards. This requires clear and concise instructions and warnings. Eighthly, mobile homes are often resold or relocated, which can affect the integrity of the electrical system. This requires careful inspection and maintenance. Ninthly, mobile homes are often located in areas with limited access to qualified electricians, which can make it difficult to obtain repairs or upgrades. This requires proactive maintenance and planning. Tenthly, mobile homes are often subject to budget constraints, which can limit the scope of electrical upgrades and repairs. This requires careful prioritization of safety and functionality. By understanding these challenges, it is possible to develop effective strategies for ensuring safe and reliable electrical installations in mobile homes. Selecting the appropriate materials for electrical installations is crucial for ensuring safety, reliability, and longevity. The choice of materials depends on various factors, including the application, environmental conditions, and budget. Firstly, copper is a widely used conductor material due to its excellent conductivity, corrosion resistance, and ductility. Copper is suitable for a wide range of applications, including wiring, grounding, and bonding. Secondly, aluminum is another common conductor material that is lighter and less expensive than copper. Aluminum is often used for service entrance conductors and large feeders. Thirdly, steel is a strong and durable material that is often used for enclosures, conduits, and supports. Steel provides excellent protection against physical damage and environmental factors. Fourthly, PVC is a versatile plastic material that is often used for conduits, boxes, and fittings. PVC is lightweight, corrosion-resistant, and easy to install. Fifthly, fiberglass is a strong and lightweight material that is often used for enclosures and supports. Fiberglass is corrosion-resistant and non-conductive. Sixthly, rubber is a flexible material that is often used for insulation and jacketing. Rubber provides excellent electrical insulation and protection against moisture and abrasion. Seventhly, porcelain is a high-temperature material that is often used for insulators and bushings. Porcelain provides excellent electrical insulation and resistance to heat and arcing. Eighthly, nylon is a strong and durable plastic material that is often used for fasteners and connectors. Nylon is corrosion-resistant and non-conductive. Ninthly, stainless steel is a corrosion-resistant alloy that is often used for fasteners and enclosures. Stainless steel is suitable for harsh environments. Tenthly, concrete is a strong and durable material that is often used for foundations and supports. Concrete provides excellent stability and protection against physical damage. By carefully selecting the appropriate materials for electrical installations, it is possible to ensure a safe, reliable, and long-lasting system. When working with electricity, it is crucial to understand the fundamental concepts of voltage, current, and resistance. These concepts are essential for designing, installing, and troubleshooting electrical circuits. Firstly, voltage is the electrical potential difference between 2 points. It is the driving force that pushes electrons through a circuit. Voltage is measured in volts. Secondly, current is the flow of electrical charge through a circuit. It is the number of electrons that pass a given point in a given time. Current is measured in amps. Thirdly, resistance is the opposition to the flow of current in a circuit. It is the property of a material that hinders the movement of electrons. Resistance is measured in ohms. Fourthly, Ohm's law states the relationship between voltage, current, and resistance. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. Fifthly, power is the rate at which electrical energy is transferred in a circuit. It is the product of voltage and current. Power is measured in watts. Sixthly, series circuits are circuits in which the components are connected in a single path. The current is the same throughout a series circuit, but the voltage drops across each component. Seventhly, parallel circuits are circuits in which the components are connected in multiple paths. The voltage is the same across each component in a parallel circuit, but the current divides among the paths. Eighthly, alternating current, or AC, is a type of electrical current that periodically reverses direction. AC is the type of current that is used in most homes and businesses. Ninthly, direct current, or DC, is a type of electrical current that flows in one direction only. DC is the type of current that is used in batteries and electronic devices. Tenthly, impedance is the opposition to the flow of alternating current in a circuit. Impedance is similar to resistance, but it also takes into account the effects of capacitance and inductance. By understanding these fundamental concepts, you can gain a better understanding of how electrical circuits work and how to troubleshoot electrical problems. Grounding is a critical safety measure in electrical systems, designed to protect people and equipment from electrical shock and damage. A properly grounded system provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to trip and to energize the circuit. Firstly, the grounding electrode system is the foundation of the grounding system. It consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metal water pipes that are buried in the earth. Secondly, the grounding conductor connects the service equipment to the grounding electrode system. The grounding conductor must be sized appropriately for the size of the service entrance conductors. Thirdly, the equipment grounding conductor provides a path for fault current to flow back to the source from non-current carrying metal parts of electrical equipment, such as enclosures, conduits, and motors. Fourthly, the neutral conductor carries the unbalanced current in a three-wire electrical system. The neutral conductor is typically grounded at the service entrance. Fifthly, ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly shut off the power to prevent electrical shock. GFCIs are required in wet locations such as bathrooms and kitchens. Sixthly, bonding is the process of connecting all non-current carrying metal parts of an electrical system together to create a low impedance path for fault current. Seventhly, static electricity is a buildup of electrical charge on the surface of an object. Static electricity can cause shocks and can damage sensitive electronic equipment. Eighthly, surge protection devices, or SPDs, are devices that protect electrical equipment from voltage surges caused by lightning or other events. Ninthly, isolation transformers are transformers that isolate the electrical system from the power source. Isolation transformers can be used to reduce the risk of electrical shock. Tenthly, proper grounding is essential for ensuring the safety and reliability of electrical systems. By following the NEC requirements for grounding, you can help protect people and equipment from electrical hazards. When installing an electrical service for a mobile home, it is important to consult with the local authorities to determine the specific permitting and inspection requirements. Permitting and inspection processes are designed to ensure that electrical installations meet the applicable codes and regulations, and that they are safe and reliable. Firstly, a permit is a legal document that authorizes you to perform electrical work. Permits are typically required for new installations, alterations, and repairs to electrical systems. Secondly, an inspection is a process in which a qualified electrical inspector examines the electrical work to ensure that it meets the applicable codes and regulations. Inspections are typically required at various stages of the electrical work, such as after the rough-in wiring is complete and after the final connections are made. Thirdly, the permitting and inspection requirements vary depending on the jurisdiction. It is important to contact the local authorities to determine the specific requirements for your area. Fourthly, the permitting process typically involves submitting an application to the local authorities, along with detailed plans and specifications for the electrical work. Fifthly, the inspection process typically involves scheduling an inspection with the local authorities, and then having the electrical work inspected by a qualified electrical inspector. Sixthly, the electrical inspector will typically check the electrical work for compliance with the NEC and other applicable codes and regulations. Seventhly, if the electrical work does not meet the applicable codes and regulations, the electrical inspector will typically issue a list of deficiencies that must be corrected before the electrical work can be approved. Eighthly, once the deficiencies have been corrected, the electrical inspector will typically re-inspect the electrical work to ensure that it meets the applicable codes and regulations. Ninthly, if the electrical work meets the applicable codes and regulations, the electrical inspector will typically issue a certificate of approval. Tenthly, the certificate of approval is a legal document that certifies that the electrical work meets the applicable codes and regulations. By following the permitting and inspection requirements, you can help ensure that your electrical installation is safe, reliable, and compliant with the applicable codes and regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years, and it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Firstly, the NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Secondly, the NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work, such as wiring methods or grounding. Thirdly, the NEC is a complex document, and it is important to have a thorough understanding of its provisions before attempting any electrical work. Fourthly, the NEC is not a law, but it is often adopted by state and local jurisdictions as the basis for their electrical codes. Fifthly, the NEC is intended to protect people and property from electrical hazards. Sixthly, the NEC is constantly evolving to keep pace with new technologies and safety concerns. Seventhly, the NEC is a valuable resource for electricians, electrical contractors, and other professionals who work with electricity. Eighthly, the NEC can be accessed online or in print. Ninthly, the NEC is a living document, and it is important to stay up to date with the latest revisions. Tenthly, the NEC is an essential tool for ensuring the safety and reliability of electrical installations. By following the NEC requirements, you can help protect yourself and others from electrical hazards. Mobile home parks often have unique electrical distribution systems that require special consideration. These systems are typically designed to provide electrical service to multiple mobile homes from a central location. Firstly, the electrical distribution system in a mobile home park typically consists of a main service panel, underground feeders, and individual service pedestals for each mobile home. Secondly, the main service panel is typically located at the entrance to the mobile home park. It is the point where the electrical power enters the park from the utility company. Thirdly, the underground feeders are typically buried beneath the ground. They carry the electrical power from the main service panel to the individual service pedestals. Fourthly, the service pedestals are typically located at each mobile home site. They provide a connection point for the mobile home's electrical system. Fifthly, the service pedestals typically contain a meter, a circuit breaker, and a receptacle for connecting the mobile home's power cord. Sixthly, the electrical distribution system in a mobile home park must be designed and installed in accordance with the NEC. Seventhly, the electrical distribution system in a mobile home park must be properly maintained to ensure safe and reliable operation. Eighthly, the electrical distribution system in a mobile home park must be inspected regularly to identify any potential hazards. Ninthly, the electrical distribution system in a mobile home park must be upgraded as needed to meet the increasing electrical demands of the mobile homes. Tenthly, the electrical distribution system in a mobile home park must be protected from damage caused by weather, vehicles, and other factors. By following these guidelines, you can help ensure that the electrical distribution system in your mobile home park is safe, reliable, and compliant with the applicable codes and regulations. Troubleshooting electrical problems can be challenging, but with the right tools and knowledge, you can often identify and resolve the issue. Firstly, start by identifying the symptoms of the electrical problem. What is not working, and when did the problem start? Secondly, gather information about the electrical system. Review the electrical panel schedule and check for any recent changes or repairs. Thirdly, use a multimeter to test for voltage, current, and resistance in the circuit. This will help you identify the location of the problem. Fourthly, check for loose connections, damaged wires, and corroded terminals. These can often be the cause of electrical problems. Fifthly, test the circuit breakers and fuses. Make sure they are the correct size and that they are not tripped or blown. Sixthly, check the receptacles and switches. Make sure they are properly wired and that they are not damaged. Seventhly, test the appliances and equipment that are connected to the circuit. Make sure they are working properly and that they are not drawing too much current. Eighthly, consult with a qualified electrician if you are unable to identify or resolve the electrical problem. Ninthly, never work on electrical equipment while it is energized. Always turn off the power of the circuit breaker before working on any electrical equipment. Tenthly, follow all applicable codes and regulations when troubleshooting electrical problems. By following these guidelines, you can help troubleshoot electrical problems safely and effectively.